everybody, my name's Anne and I've just started a new channel called Learn with Anne. I'll be teaching science, maths and English. Today I'll be doing science. And the topic is acids, bases and salts. Acids and bases. So we have a table here and we are going to fill this out in the textbook, okay? Lemon juice, what is the taste? Is it sour, bitter, salty, sweet? Anything like that. So lemon juice is bitter. Orange juice is sour. Vinegar is also sour. Curd is also sour. Tamarind or imli is sour. Sugar, of course, it's sweet. Common salt is salty. Amla is sour. Baking soda is bitter. Grapes is sweet. Sometimes it's a bit sour as well. Unripe mango is sour. Cucumber is bitter. Okay, so we've just filled out our table and this is going to help us with the acids, bases and salts lesson that we are going to do today. Now, let's see the definition of acids. Curd, lemon juice, orange juice and vinegar taste sour. These substances taste sour because they contain acids. The chemical nature of such substances is acidic. The word acid comes from the Latin word acere, which means sour. The acids in these substances are natural acids. I'm going to underline the definition of it. The word acid comes from the Latin word acere, which means sour. Okay? And that is the definition for acids. If anyone asks you that, now you know what the definition of acid is. So the definition of acid is that it comes from the Latin word acere, which means sour. Okay? Now, let's do bases. What about baking soda? Does it also taste sour? If not, what is its taste? Since it does not taste sour, it means that it has no acid in it. It is bitter in taste. There we are, bitter in taste. If you rub its solution between fingers, it feels soapy. Generally, substances like these, which are bitter in taste and feel soapy on touching, are known as bases. The nature of such substances is said to be basic. Okay, that I've underlined the key ones. It is bitter in taste, feels soapy. Bitter in taste and feels soapy on touching are known as bases. Okay, that's the definition of bases. Now you know the definition of acids and bases. Now we have some examples of acids and bases. So the name of acid is acetic acid. That's how you pronounce that, acetic acid. And it's found in vinegar. In vinegar, it's acetic acid, okay? You need to by heart this whole table. If you're in, so you guys who are in standard 7, you need to by heart this table in order if you have any test or exam which says any of these things and you need to answer them. So in acetic acid, there is acetic acid in vinegar. Now, ants sting. In ant sting, it's formic acid. Formic acid. Citric acid. Citric acid should refer to citrus fruits. You can see that there. Citrus fruits. Such as oranges, lemons, etc. Okay, so you know the oranges, lemons, and they're like the citrus fruits. You can, when you bite into them, oranges, you can, especially oranges, you can like taste that bitter, not a sour taste, and lemons the same. Okay. Lactic acid, curd. This one's quite hard. Oxalic acid, spinach. Oxalic acid, spinach. Ascorbic acid, it's vitamin C. I'm sure you all must have heard of vitamin C. Amla and citrus fruits. If you've ever heard your mum or your parents say you need to have vitamin C, so that's why, so you're giving fruits like oranges and things. That's why you eat them, because they have vitamin C in them, and then that vitamin C is necessary for our body. Tartaric acid, tamarind, grapes, unripe mangoes, etc. So they're all like bitter, sour sort of things. Okay, so we're going to go into bases now. We did acids in the above, and we're going to go into bases. Bases are a bit more harder to remember, but the only thing you don't have to remember in that is hydroxide, because everything ends with hydroxide, okay? Calcium hydroxide, found in lime water. Ammonium hydroxide, in window cleaner. Sodium hydroxide and potassium hydroxide, found in soap. Magnesium hydroxide, found in milk of magnesia. Magnesium and magnesia sounds the same, so you can kind of remember it as milk of magnesia because it's M, isn't it? Okay? And you don't need to remember really the hydroxide part. Just remember every single one for the base is a hydroxide. So just remember calcium, lime water. Ammonium, window cleaner. Sodium and potassium, soap. Magnesium, milk of magnesia. Okay? Now, we are going to do the definition of indicators. Okay? Special type of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. The indicators change their color when added to a solution containing an acidic or a basic substance. Turmeric, litmus, China rose petals, gudhal, etc. are some of the natural occurring indicators. Those turmeric, you need to first of all remember the turmeric, litmus, and China rose petals, or you can say China rose solution, because if you have China rose petals in an experiment, you have to make it into a solution before you actually do the experiment. Okay? And the definition is special type of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. And the naturally occurring examples of indicators is turmeric, litmus, China rose petals. That's really easy to remember, okay? And remember that indicators change their color when added to a solution containing an acidic or a basic substance. Just try and remember that. That's not the definition, but that's part of it, okay? Now, litmus as an indicator. Litmus and, excuse me, natural indicators around us. Litmus, a natural dye. So it's a natural dye. The most commonly used natural indicator is litmus. It is extracted from lichens. We need to remember that it's extracted from lichens. It has a mauve purple color in distilled water. When added to an acidic solution, it turns red. Here we are, there's the red. And when added to a basic solution, it turns blue. There's the blue. It is available in the forms of a solution or in the forms of strips of paper known as litmus paper. Generally, it is available as red and blue litmus paper. So you can see right here, red and blue litmus paper. This is lichens, where it's extracted from, okay? That's litmus as an indicator. Turmeric as an indicator. Okay. We just did this. We're going to read an experiment which is for litmus paper first, and then we're going to do turmeric is another natural indicator. Okay? Activity 5.1. So we're activity 5.1 here. Mix some water with lemon juice in a plastic cup tumbler or plastic cup or a tumbler or a test tube. Put a drop of the above solution on a strip of the red litmus paper with the help of a dropper. Is there any change in color? Repeat the same exercise with the blue litmus paper. Note down if there is any change in color. Perform the same activity with the following substances: tap water, detergent solution, aerated drink, soap solution, shampoo, common salt solution, sugar solution, vinegar, baking soda solution, milk of magnesia, which contains magnesium hydroxide, vinegar, which contains acetic acid, and is there any others? No. Washing soda solution and lime water. Vinegar is acetic acid, lime water. Lemon is citric acid. If possible, make solutions in distilled water. Distilled water is like, water that you get in bottles. That's what it is. Record your observations as in table 5.2. In your table, are there any substances on which litmus has no effect? Name those substances. Now we're going to go on to just this tiny little bit of information about neutralization. The solutions which do not change the color of either red or blue litmus are known as neutral solutions. These substances are neither acidic nor basic. That is basically the definition of neutralization. Solutions which do not change the color of either red or blue litmus paper are known as neutral solutions. Okay, these substances are neither acidic nor basic. So give me an example. Try and guess. From all the things that we just read now, we had quite a lot here. Which ones do you think will be neutral? Tap water will be, distilled water will be, and we'll find out some more, I think, once we go into neutralization. But we're going to do turmeric is another natural indicator first. Activity 5.2. Take a tablespoon of turmeric powder, add a little water and a paste. Make turmeric paper by depositing turmeric paste on blotting paper or filter paper and drying it. Cut thin strips of the yellow paper obtained. Put a drop of soap solution on the strip of turmeric paper. What do you observe? Similarly, test the solutions list in table 5.3 and note down your observations. You may try solutions of other substances also. Okay. We're going to do the China rose as an indicator now, and then we can move on to neutralization. Collect some China rose guthal petals and place them in a beaker. Add some warm water. Keep the mixture for some time till water becomes coloured. Use the coloured water as an indicator. Add 5 drops of the indicator to each of the solutions given in table 5.4. What is the effect of the indicator on acidic, basic and neutral solutions? China rose indicator turns acidic solutions to dark pink magenta. So acidic solutions, you can see there, that's for the China rose. And basic solutions to green. There is a riddle here. Coffee is brown and bitter in taste. Is it an acid or a base? Don't give the answer without any test. You are in the dark with its taste. So we know coffee is brown. We know coffee tastes bitter. Is it an acid or a base? Bitter tasting things are usually bases. But does it feel soapy on touch? No, it doesn't. So it is either an acid or a base. I'm not telling you the answer. You can try this out for yourself, or you can Google the answer and tell in the comments below. Now there's one more experiment, and then after that we'll go on to neutralization. The teacher is requested to get the dilute solution of the following chemicals from his or her school laboratory or from a nearby school: hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, ammonium hydroxide, calcium hydroxide. Right, we did some of these. If you can remember, acetic acid, vinegar, what else? Ammonium hydroxide, window cleaner, calcium hydroxide, lime water. Ooh. Is there any more? Sodium hydroxide and potassium hydroxide had soap. Magnesium hydroxide was milk of magnesia. So don't think there is any others in our table that we learnt. Demonstrate the effect of the 3 indicators of each of these solutions. Record your observations in table 5.5. Okay. There is actually a really good did you know fact thing that we are going to do now. Are you familiar, in this blue box, we're going to do this, okay? Are you familiar with the term acid rain? Have you ever heard about damaging effect of acid rain? As the name indicates, the rain containing excess of acids is called an acid rain. Where do these acids come from? The rain becomes acidic because carbon dioxide, sulfur dioxide, and nitrogen dioxide, which are released into the air as pollutants, dissolve in raindrops to form carbonic acid, sulfuric acid, and nitric acid, respectively. Acid rain can cause damage to buildings, historical monuments, plants, and animals. That is a really cool thing. I've never heard of that before, and that's cool. Okay, we're going to do neutralization now. Back to PowerPoint. Neutralization. I don't think I spelt it correct. Neutralization there. Neutralization. We have learned that acid turns blue litmus red and bases turns red litmus blue. Let us see what happens when an acid is mixed with a base. We are now going to use an indicator which is not a natural indicator, by the way. It is called phenolphthalein. Phenolphthalein. That is how you pronounce that word. It's a quite hard word. Now you can see it here. That is the color, process of neutralization with phenolphthalein. Okay. Again, I've spelled it incorrect. It is evident that when the solution is basic, phenolphthalein gives a pink color. There we are. On the other hand, when the solution is acidic, it remains colorless. So, there. When an acidic solution is mixed with a basic solution, both the solutions neutralize the effect of each other. Okay, when an acidic solution is mixed with a basic solution, both the solutions, when they're mixed together, neutralize the effect of each other, and that's the process of neutralization. In neutralization reaction, heat is always produced or evolved. The evolved heat raises the temperature of the reaction mixture. In neutralization, reaction of a new substance is formed. This is called salt. Salt may be acidic, basic, or neutral in nature. Thus, neutralization can be defined as follows. The reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat. Acid plus base gives salt plus water where heat is evolved. I know this by heart. Hydrochloric acid HCl plus sodium hydroxide NaOH gives sodium chloride NaCl plus water H2O. You need to by heart these two ones. This is the general one and this is the example one. You need to by heart them. Okay? And the reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat. Should also do that. Okay, I think that is it for this lesson. Where there's neutralization in everyday life as well in the textbook. We'll only briefly go over that, but yeah, I think we're pretty much done. Indigestion is an example. I'd like you to read this and underline the most important things that you think are important. And we have some questions as well, okay? Questions. Keywords. You need to know the definitions of this. Acid. Acid tastes sour. Acidic. Acid comes from the word acier and it tastes sour. Okay. Base feels soapy on touch and it tastes bitter. Basic. Indicator. It's to test whether a substance is an acidic substance or a basic substance. Neutral. The reaction. Neutral is where an acidic substance and a basic substance mix together and they neutralize the effect of each other. Neutralization. The reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat. Acid plus base gives salt plus water where heat is evolved. Salt. Okay. Acids are sour in taste. Generally, bases are bitter in taste and soapy to touch. Acid turns blue litmus red, bases turn red litmus blue. Substances which are neither acidic nor basic are called neutral. Solutions of substances that show different color in acidic, basic, and neutral solutions are called indicators. An acid and a base neutralize each other and form a salt. A salt may be acidic, basic, or neutral in nature. Okay, we have some exercises. And I think I will be doing half an hour lessons or maybe 15 minutes lessons every single video. I'm not sure how long it will take. So I'm still new to this, and we'll do some exercises in this. So let's see. State the differences between acids and bases. Acids are sour in taste, and it comes from the Latin word acere. Bases are soapy and on touching and bitter. Okay. Ammonia is found in many household products, such as window cleaners. It turns red litmus blue. Red litmus blue. We just read this. What is its nature? It's basic, okay? Basic. Basic. Name the source from which litmus solution is obtained. What is the use of this solution? It's extracted from litmus. And what's the use of this solution? To test if a substance is acidic or basic. So it's an indicator. Is the distilled water acidic, basic, or neutral? Neutral. How would you verify it? By testing with litmus, a natural indicator, or phenolphthalein, something like that. So use an indicator to test. Describe the process of neutralization with the help of an example. We did this, so we can skip past this one. Okay, nitric acid turns red litmus blue. False. Sodium hydroxide turns blue litmus red. False. Sodium hydroxide and hydrochloric acid neutralize each other and form salt and water. True. Indicator is a substance which shows different colors in acidic and basic solutions. True. Tooth decay is caused by the presence of a base. False. It's the presence of an acid. Dorji has a few bottles of soft drink in his restaurant, but unfortunately these are not labeled. He has to serve the drinks on the demand of customers. One customer wants acidic drink, another wants basic, and the third one wants neutral drink. How will Dorji decide which drink to be served to whom? So you have to test it with litmus paper. Litmus paper. Okay, we can do question number 9 as well. Question number 9. Okay. 3 liquids are given to you. One is hydrochloric acid, another is sodium hydroxide, and the third is a sugar solution. How will you identify them? You have only turmeric indicator. So you need to do the experiment that we just read. Okay? I would like you to answer that by yourself if you can. Blue litmus paper is dipped in a solution. It remains blue. What is the nature of this solution? It's a base. Consider the following statements. Both acids and bases change color of all indicators. True. If an indicator gives a color change with an acid, it does not give a change with a base. False. If an indicator changes color with a base, it does not change color with an acid. False. Change of color in an acid and a base depends on the type of the indicator. That is true. Which of these statements are correct? A and D. There's some extended learning things, and you can try the experiment for yourself. I hope you all enjoyed this lesson, and yeah, that is my science lesson today. Thank you, everybody, and I hope you found this lesson informative, fun, and I hope you enjoyed it as well as I did. Thank you, everybody. Bye. See you in my next video.